We're covering consolidation settlement for the FE civil exam, focusing on the compression index, CC, the coefficient of consolidation, CV, and the time rate of settlement. This topic involves two distinct calculations found in the Geotechnical Engineering section of the NCEES FE Reference Handbook. First, determining the total amount of primary settlement, and second, figuring out how long it will take for that settlement to occur. Primary consolidation is the settlement that occurs in a saturated clay layer as water is gradually squeezed out under a new load, like a building foundation. The formula for the magnitude of this settlement is S equals the quantity CC times H divided by 1 plus E naught, all multiplied by the log of the final effective stress over the initial effective stress. Here, CC is the dimensionless compression index, H is the clay layer thickness, and E naught is the initial void ratio. The most critical part and a common exam trap is correctly calculating the initial and final vertical effective stresses at the midpoint of the clay layer. Remember, effective stress is total stress minus pore water pressure. You'll need to calculate the initial overburden pressure, P'1, and then add the stress increase from the new load to find the final pressure, P'2. Once you have the magnitude, the next step is to determine the time rate of settlement. This uses the dimensionless time factor, TV. From the formula, TV equals CV times T, all divided by HDR squared. In this equation, CV is the coefficient of consolidation, which has units of area per time, like square feet per day, and T is the time you are solving for. The variable that causes the most trouble on the exam is HDR, the length of the maximum drainage path. If the clay layer is between two permeable layers like sand, water can drain out from the top and bottom. This is two-way drainage, and HDR is half the layer thickness. If the clay is on an impermeable layer like bedrock, it can only drain upwards. This is one-way drainage, and HDR is the full layer thickness. A mistake here is critical because this term is squared. The FE exam often links the time factor, TV, to the average degree of consolidation, U. A key value to know is that for 50% consolidation, TV is 0.197. For example, if a 10-foot thick clay layer with a CV of 0.1 foot squared day is between two sand layers, the drainage path, HDR, is 5 feet. The time to reach 50% consolidation would be T equals 0.197 times 5 feet squared, all divided by 0.1 foot squared day, which equals 49.25 days. If that same layer were on bedrock, HDR would be 10 feet, and the time would quadruple to 197 days. This highlights the importance of correctly identifying the drainage conditions. A useful mnemonic to remember the key points is calculating settlement size. Time depends on drainage path squared. This helps you focus first on the settlement magnitude with its variables like CC, and then on the time calculation where the drainage path squared is the most critical and tricky input. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.